So let's just say you are given a function. That function is f of x being equal to x squared. Now let's say you want to draw a graph. So that graph would look like this. Graph of the function. So it's x squared. So it's a parabola. So this is how it should look like. And this is how and touch it here. This is the graph of f of x being equal to x squared. And now now say I want to find the graph that show all the gradients of this f of x. So we have f of x, and we want to find the gradient of all these points. So we want to find the gradient of all these points. Now the usual way that we would do it, so let's say here we draw a line and we want to find the gradient of this line. Now gradient here is a very negative number, so let's say very negative number. So let's say if x is here, that gradient is here, and then you find the gradient of another point, say this point, and that gets you another gradient, and it should actually be here. And when you get to this point, the gradient is 0. And when you go to this side, the gradients start to go positive and it starts to look like this. And the funny thing about the gradient of f of x being equal to x squared, the gradient is actually a linear polynomial. So this is actually equal to 2x. So all the gradient of f of x make a line, and that line has the equation of y being equal to 2x. And so that is what we call differentiation. It is when we have a function, and as we differentiate it, we get a graph that show all the gradient of that function. Now let's say we want to let's talk about the most basic rule of differentiation. Now let's say we have a function of f. Say we have function of f of x is equal to x to the power of n, and the differentiation of this function, we can denote it as f x this, or we can denote it as dy over dx. Personally, I usually use this one, so dy over dx. So let's say f of x is equal to x to the power of n, then dy over dx is equal to, this is equal to n times x to the power of n minus 1. This is the basic idea of differentiation. So basically, when you're given a function f of x and it has these sort of term, you differentiate it into this. And so let's say we have a couple of examples. Let's say we have these 3 examples. So f of x equal to x to the power of 3, f of x equal to x to the power of 3, x to the power of minus 3, f of x equal to x to the power of 3 plus x to the power of minus 2. Now f of x is equal to x to the power of 3. Now if we differentiate it, what we will have is actually 3x squared, as the basic rule of x to the power of n. Differentiate get us n to the power of x and minus 1. So here n is 3, n to the power of minus 2. So this is what we call the differentiation of f of x. Here similarly, so we have now minus 3. So this is 3 times x to the power of minus 4. This is minus 3 times x to the power of minus 4. Now we have n is equal to minus 3. So n goes here, that's minus 3. n minus 1 is minus 4. So x to the power of minus 3 minus 1 is x to the power of minus 4. So this is what we get. Now when it comes to having two terms, the way you can do it is that you differentiate each of these terms at a time. So here, differentiation is 3x squared plus minus 2x to the power minus 3. Right, so that is the basic idea of differentiation. And all of these differentiation of f of x is actually the graph. It graph shows all the gradient of each of these points on this function f of x. That's the basic idea of differentiation.